Okay, so good afternoon to all of you. We are back to Omega Online Physics class once again, and we have almost a whole semester of physics engagement. Let's begin this with answering one or two questions. Some questions, okay, in your end of second semester examination. And I'm going to put some few questions to you, you answer, and then we move on. If there are questions that I need to come in, then I quickly come in, so we move forward. So that next week, I think for Monday, we begin the whole semester or arrangement for next semester, right? The first, please, those of you joining us from other schools, since I'm the man behind the console, I decide the CD to play. So if you have your own CD and you want us to play, please send maybe a question or whatever to me. Your challenging end of semester questions, okay, send it to me via WhatsApp so I can look at it, so that when we meet, I can take the time to address it. This is if you are joining us from a different school, okay? All right. What is a projectile? Yes. The first question is that what is a projectile? Let's quickly deal with it and then move on. I don't want to call, but to the class or to the house, what is a projectile? Anybody who wants to project the voice can answer. If you want to project your voice, you can answer the projectile. Hey, then I'm going to call. Okay. Akosia Aduma Jima. Akosia, what is a projectile? Okay, so I have Lizzie, Leanne, Eresi, Elvina, Chrysla. Oh, I have a lot to call. Okay, Eresi, what is a projectile? What? Okay, Chrysla, thanks for, breaking the ice for us. Chrysla, what is a projectile?
With the age of peace, a projectile is a body that has been given an initial velocity and falls under gravity.
Okay, thank you. So that's absolutely correct. It is a projectile is a body that is given an initial velocity and falls under the influence of gravity, neglecting air resistance. Okay, so but the key note here is that you have to understand that there is this difference between what a projectile motion is and what a projectile is. For a projectile, it is a body that is given an initial velocity, falls under the influence of gravity, whilst air resistance is neglected. Then a projectile motion is the motion of a body that is given an initial velocity and falls under the influence of gravity, whilst air resistance is neglected. So be careful whenever you are answering and how you craft or you put your words together. State 3 factors that affect the maximum height reached by a projectile. State 3 factors that affect the maximum height, H max, reached by a projectile. Yes. Lizzie, give me one. We have to say 3. So some 3 factors that affect the maximum height reached by a projectile.
Gravity.
Gravity is one. So we have gravity. Adwa, Utubia, gravity is 1, 2. Adwa, Utubia. Okay.
Is the initial velocity the body is moving?
The velocity of projection. Okay. Don't say the initial velocity, but velocity of projection. Velocity of projection. 3. Yes. Oh, let's hurry up. Okay, Lauren. Adwa Sewa, anybody? Oh, angle of projection. And lastly, what's the last effect? Who is there? Okay. Resistance. Resistance. That is why, because it affects projectile motion in all aspects, that is why we neglect it. So if you recall, H is equal to U sine theta squared over 2G, meaning that H is directly proportional to U. H is directly proportional, the square of U. H is also directly proportional to the square of the sine of the angle of projection. And H is inversely proportional to gravity. So with the first variable, it means when U increases, maximum height would also increase. When the angle of projection increases, H also increases. For gravity, we won't take it as an effect. The reason is that even though gravity affects projectile, but gravity is constant on the surface of the earth, meaning that gravity cannot be made to change so that it will change H. So long as we find ourselves on the surface of the earth, gravity is constant. Okay, the relationship simply means that if two variables are inversely proportional, what it means is that an increase in one would cause a decrease in the other. A decrease in the other would cause an increase. But here is the case on the surface of the earth, gravity is constant. So even though it's affected, but it will never change so long as we find ourselves on the surface of the earth. Please, is that point understood? Is it understood? Hey, feedback.
Yes, please.
Okay. So the obvious effects will be velocity of projection, angle of projection, and air resistance. As for gravity, it is constant. All right. Then please take note of this question. Two vectors we are going to solve. So two vectors, 20 Newton and 50 Newton, act at a point and are inclined at an angle of 120 degrees to each other. Two vectors, 20 Newton and then 50 Newton, acting at a point are inclined at an angle of are inclined at a point. So, sorry, let me take it again. Two vectors 20 Newton and 50 acting at a point are inclined at an angle of 120 degrees to each other. Find the magnitude and direction of their resultant. So here we are to find the magnitude and direction of their resultants. Okay, so here we are only informed that two vectors, 20 and then 50 Newton, are inclined to one another through an angle of 120. As to which one is on the x-axis or whatever, we were not told. But all that we are told is that we have two vectors of magnitude 20 Newton and 50 Newton. And the angle of tilt, theta, the angle of inclination is 120 degrees. Okay. So we are to find the resultant and the direction of this resultant. So we are going to consider it using two different methods or approaches. And we need to get the same. So let's assume this is our reference point. Okay. And so this is the point where we are going to take our measurements. The first, I'm taking the first vector to be 20 Newton. Even though I can consider the second vector, the 50. Now to locate 50 Newton, I must measure an angle of 120 degrees. And you know, angular measurement is taking, okay, counterclockwise. So this is my 120. This is 120. And there's a common point of exertion of the two vectors. So 50, this one has a magnitude of 50 Newton. It can change because the order of the forces, exertion of the forces, I'm not told. Okay, so once we can resolve this into a parallelogram and then determine the resultant. So if I'm to resolve it into a parallelogram using equal vector approach. So same magnitude, same direction, and this is parallel to this, so 50. The same approach to this one. Same magnitude, same direction. Now looking at the angles, okay, I have now realigned their direction. So the resultant is drawing a vector from the tail of this to the head of this one. And so it must act in this direction. Once this is 120, this must be 120. Okay, 120. Now this is a four-sided figure. So the sum of the angles in the quadrilateral 360. Since this is a parallelogram, this angle will be equal to this angle. So assuming this is x, this is also x. So I have 2 times 120 plus 2 times x, summing up to 360. Okay, therefore x must be equal to, when we divide through by 2, x will be equal to 360 minus 120. And what's the answer? What is 360 minus 120? Hello, class? Let me hear from you. Oh, sorry, this is 180. That's 180. Yeah, we divided through by 2. So 180 minus 120, this is 60, right?
Yes.
Good. So this is 60. This is also 60. Please, this is also the same as taking the same thing in a different way. Since this force is parallel to this force, when two forces, okay, are equal, it means their slope is the same. So if this is 120, this will also be 120, so that this will be 60. So this is a different way of determining the same angle, and we have 60. All right. So r squared is equal to 20 squared plus 50 squared minus 2 times 20 times 50 times cosine of this angle 60. And so 400 plus 2500, okay, minus 1,000, because cos 60 is half. So half to cancel this. So 20 times 50, giving us 1,000. We have 2,900 minus 1,000. And that is equal to 1,900. Okay, therefore R is equal to the square root of 1,900, which is equal to, yes, what is
43.5.
43.5 Newton. That's it. That's the resultant. How many of you are so sure that you had this answer correctly during the exams? Just raise up your hand. Okay, more hands. Okay. Okay. All right. Then let's look at the direction. When we finish, in fact, I want us to solve the same question using a different method. Okay. Direction. We are looking at the direction of the resultant force from the reference point. And what's the reference point? We measure the resultant from this line, what I can say to be the x-axis on which the 20 Newton is. So if I want the direction of the resultant, then I have to measure the angle from the reference point to the resultant. Okay, the direction from the reference point to the resultant. Okay, so let me label this angle as maybe alpha. So using sine rule, can you see? I'm coming. Let me adjust. Okay. Using sine rule, the sine of the angle alpha, sine alpha, the ratio of the sine of the angle to the side opposite to it, 50, is equal to the sine of any known angle within it. So sine 60 divided by the resultant force, which is this, 43.5. Okay, so sine alpha therefore is equal to 50 times sine 60 on 43.5. Sine 60 is √3 on 2. root 3 on 2. So we have 25 root of 3 divided by 43.5. So when you take the sine inverse of this ratio of 25 root 3 on 43.5, it must give you alpha. Please calculate that for me. What did you get for alpha? Take the sine inverse of this fraction. Eresi and Lizzie, what did you get? Hey, please, let's respond quickly. Time isn't on our side. Eresi, Lizzie, Adjoa, what did you get?
84.5.
24.5. All right.
84.
So
84. 84.
84.
Mistake here.
84.
Yes, please.
Check,
Yes,
check,
please.
check again. Check again. So 25 times root 3 divided by 43.5. Let's get that decimal figure. When you divide this by this, what will this amount to? Just a confirmatory something. 25. Please, all hands on deck, okay?
Yes, please.
Divided by 43.5. Okay, 84.5. All right. So I've also confirmed it. 84.5 degrees. All right. So, but the point is that if you change the forces, if you bring the 20, pay attention, if you bring the 20 Newton here and you bring the 50 Newton here, the magnitude will not change. You have the same value, but the direction will change. Okay. It's the direction will change, but the magnitude will be the same. So once we never ask you to put 20 Newton on X and then you happen to change it, I think you cannot be penalized for that because we never stated it clearly that this must be here. The magnitude would not change, but the direction will certainly change. Let's use, do I clean the board? Hello, do I clean the board? I want us to use the method of resolution of vectors to solve the same problem. Now, in resolution of vectors, we pick each and every vector, our force, and then resolve it to the horizontal and then vertical component. So the 20 Newton force is along the X. So in resolving it into components, we have 20 Newton cos of 0 because here it makes an angle of 0 with the X axis. There's the X axis. And it makes an angle of 0 with the X. So 20 cos 0 then 20 sine of 0. And since cos 0 is equal to 1, this is 20, and then sine 0 is equal to 0. So 20 and 0 Newton respectively. So these are the components of the 20 Newton force. Then we pick the other one. The other force makes an angle of, what angle does it make with the x-axis? Class, what angle does the 50 Newton force make with the x-axis? Yellow. What angle does the 50 Newton force make with the x-axis? Quick one.
120 degrees.
120. I just want you to be part of the discussion. Don't be an observer. So the 50 Newton force makes an angle of 120. So 50 cos of the angle it makes with the x-axis, and then 50 sine of the angle it makes with the x-axis will be the components. Therefore, cos 120 is equal to the negative of cos 60. And so cos 120 is negative half. So this will give us minus 25 Newton, since cos 120 is equal to negative half. Charlotte, are you there?
Yes, please.
Then sine 120 is equal to sine 60. And sine 60 is root 3 on 2. So 25, this is 25 root of 3 Newton. So we've resolved each and every one into components. Now let's find summation of the x's for each one of the resolved forces. So we have 20 minus 25, and then summation f of y, we have 0 plus 25 root of 3. So this plus this, and then this plus this one. Okay, this is giving us minus 5. And then this is also giving us 25 root of 3. Okay, let's redraw. When you draw, the x component is along this axis. Because it's negative, it will come along the negative x axis. So this is minus 5 Newton. Minus because we have eliminated the minus because we've taken care of the minus. That's why we brought it to the negative x axis. And then the positive is the y axis. Summation y is a positive value, which is 25 root of 3 Newton. So when you draw an equal vector, you realize that the resultant will be along the diagonal. The resultant is along the diagonal. So using Pythagoras theorem, we can find the resultant. Using Pythagoras theorem, R will be equal to the square root of 5 squared plus 25 root of 3 all squared. Please, let's calculate that for me. Calculate this for me. R, this is 25. 5 squared is 25. Plus, what is 25 squared? What is 25 squared?
25.
Let's see.
625.
Okay, times 3. 1875. So 1875 plus 25. That is 19,900. So once we have R being equal to 1,900, it means we will have the same thing as a resultant. Please, is that okay? Class, is that okay? If you have any question, you can ask. If you have any question, we are learning. So then let's move on to the direction. Let's look at the direction. Direction, take this angle we'll take the angle to the x-axis, alpha. If we take the tangent of the angle, tangent is opposite over adjacent. So 25 root of 3 divided by 5. So we have 5 root 3. Alpha is equal to the tan inverse of 5 root 3. Please compute that for me. The tan inverse of 5 root 3. Let's hurry up.
83.4.
Exactly as we had. So 83.4. Alpha is equal to 83.4. So there are a lot of ways to go around the same question. Okay. All right. The next question. Define relative velocity. Sorry, relative density. Let me pick some names and then call. Alvina. Define relative density. Do I clean the board? Alvina, I'm waiting.
Sir, please. Relative density is the measure of the density of a body in reference to water.
You are not wrong. You are not 100% correct. You left out some ingredients.
Okay, sir, please let me try again.
Okay, come again.
Relative density is the ratio of the density of a substance to the density of water.
You left out a very key adjective. Somebody to, put in the adjective for us. What is that key point mixed in her definition? Oh, my people, this Adwa Asante. Go on, Adwa.
The ratio of the density of a substance to the density of pure water.
Adwa, you left out a key adjective. The ingredient is still not intact. Yes, Lizzie, Charlotte. Oh, today, I don't feel your vibe today. Leon.
Is the weight of a liquid compared with the weight of water.
You left out a key adjective. Okay, Lauren.
This is equal to the weight of the liquid.
You left out a key adjective. Lauren.
Please, relative density is the ratio of the density of a substance compared with the density of pure water.
You left out a key adjective. Okay, let me give my version. Okay, Doma, Jema, the last trial. Go ahead.
It is the ratio of the density
of liquid compared to 1 gram of water, or 1 gram per centimeter cube of water.
Aquia is a bit, you're a bit close. Okay, let me bring in my version. It is the density, okay, of a substance, okay, or yes, a substance compared to the density of equal volume of water. Equal volume of water. Very, very important. Meaning, if I take X volume, centimeter cube of a substance, I need to compare it with X cm cube of water. So it is the density, the ratio of a density of a substance, okay, to the density of equal volume of water. So that missing link, okay, in your definition was the equal volume of water. Please, are you okay?
Yes, please.
All right. A question. An object is placed in kerosene of volume 25 cm cube. The kerosene level rose to the 90 centimeter cube mark. Find the upthrust on the body. The relative density of kerosene is equal to 0.75. Density of water 1 gram per cm cube. And gravity is 9.8. So an object is placed in kerosene of volume 45 centimeter cube. The kerosene level rose to the 90 centimeter cube mark. Find the upthrust on the body when the relative density of kerosene is 0.75 and density of water is 1 gram per cm cube with a gravity value of 9.8. Refresh your thoughts on this question. I'm giving you 2 minutes to go through. Yes, this is a question you solved, but I'm giving you extra 2 minutes to think through, try solving it before I come in, okay? So I am going for commercial break. I'll join the link in 2 minutes time, but I'm not going off. I'm not going off. Engage your brain within 2 minutes and I'll be with you. Okay, back from the commercial break. Now, RD. Here, we are to determine the upthrust on the body whilst in a liquid kerosene. So the relative density is being expressed in terms of upthrust. So upthrust in kerosene over upthrust in water. And in our question, we are to determine the upthrust on the body. Okay, so the upthrust experienced by the body in kerosene is what we are looking for. So if we make upthrust in kerosene the subject, we have RD by the upthrust in water. The relative density of kerosene is 0.75 times. Upthrust is weight of liquid display. So upthrust in water is a weight of water display. So mass of water times gravity would give us acres in water. Now, mass of water can be expressed in terms of density of water and volume. Okay. Let me see. So, all right. So, mass of water are we given? An object is placed in a kerosene of rose to. Okay, so this will be density of water times volume of water times gravity. So 0.75 times 1 gram per cm cube times the volume of water. The volume of water displaced by the body in kerosene and in water will not be different, because the volume of liquid displaced is always equal to the volume of the object once the object is fully submerged in the liquid. So if we find the volume of the objects, we have the volume of water that will be displayed. And so the initial volume was 45 and then rose to 90. So 90 minus 45 would give us the volume of the object. Please, are you with me?
Yes, please.
Okay, so this is 45 cm cubed. And so that will be the volume of water displayed, 45 cm cubed. So let me bring the units. This is gram per cm cubed. This is gram per cm cubed. This is cm cubed. We are going to multiply this with gravity. Okay, so this and this will cancel out. Okay, now, so let's finish the multiplication here. 0.75 times 45. What is 0.75 times 45? Please do the multiplication for me. Oh, let's not waste time with this, please. 0.75 times 45. Oh, Lizzie, I queer.
33.75.
So this is 33.75. Okay. Now, at the end of it, what we are going to do is that we are going to multiply this by gravity. And since all that we've determined, okay, we multiply this by 1 gram mass has a weight of 0.01 Newton. So we multiply, instead of converting the masses into kilogram, just multiply this by 0.01. The reason is that 1 gram mass weighs 0.01. So if you have 33.75 grams of a substance and you are converting it to weight, then you only multiply by 0.01 Newton. Instead of converting the mass into kilogram before multiply by 10 meters per second squared. So multiply 33.75 by 0.01. And that, I think that would give us
0.375.
0.3375 Newton. Okay. Please, are you okay? So that will be the actress.
Okay.
upthrust experienced by the body in the kerosene. Okay, we can do the same thing by upthrust in kerosene is also weight of, so density of kerosene, volume of kerosene times gravity. So let's see, density of kerosene. The density of kerosene is equal to 0.75 gram per cm because this is the relative density. Okay, and then the volume of kerosene, volume of kerosene is the same as the volume of the object, 45 times gravity. When you multiply this, you have it in grams. Since 1 gram weighs 0.01 Newton, simply multiply this by 0.01 Newton. And you get the same thing as whatever we've had here to be the upthrust in kerosene. All right. Okay. Now, state 2 methods of reducing friction. By the way, what is friction? What is friction? What is friction? All right. Lynn, what is friction? Lynn, what is friction? Or Nanama, please, let's not waste time. Quick. Nanama, what is friction? Okay, Apia.
It is the force that acts on two surfaces in contact.
Charlotte, not completely. Come again. You are not wrong. You are not totally correct. Nanama, what is friction? Oh, yeah. Adjoa Asante, what is frictional force? What is friction?
It is the force that opposes motion when two surfaces are in contact.
Okay, so yes, it is the force that opposes the relative motion between two bodies in contact. The force that opposes the relative motion between two bodies in contact. Is that okay? So frictional force would always oppose motion. It is always parallel to the surface, the two surfaces in contact, but it will also always oppose the relative motion. So with friction, when a body is moving north, friction is moving south. When a body is moving south, friction is directed to the north. Its work is to oppose the relative motion between two bodies. Now we have to state 2 methods of reducing friction. JHS. So let me have Eresi help me. Give me one method of reducing friction. Eresi. Then Galazi A21. Help me with another.
Sir, please, please, we can, how do you call it? By application of oil.
Good. By application of oil. You are right. 2. Nanama. By application of oil. Oh, I don't like the dull, okay, state of the class. Okay.
Galvanization.
Elvina,
Reason.
Come again. Alvina, greasing. Okay. Lizzie. Alvina, your hand is still up.
Please, I
Oh,
said breathing. I said
yes, you are correct. You are correct. Chrysler,
By
Liz-
lubrication.
lubrication. Adwa Sewa, speak. Okay, Lizzie, go ahead.
Polish it.
Yes, polishing. By polishing, in fact, by polishing, all that you are doing is that you are greasing, smoothing. Okay, when you lubricate, you grease and all that, you feel the minute pores, which creates the friction, the interlocking of the surfaces. Okay, so you are feeling greasing, does that, oiling does that. Erasy.
Sir, please, can you say by the use of ball bearings?
Exactly. By the use of ball bearings and rollers. Okay. By the use of ball bearings and rollers. All right. I think we need to move on. State 3 losses of. Hey, did I say losses? Loss of friction. 3 loss of friction. Yes, you are to state 3 laws of friction. Who will bring the eyes for us? A volunteer to start for us. Lauren, you've been quiet. Galaxy A21, you've been quiet. 3 laws. Adjoa, let me start with Adjoa Asante.
Friction opposes motion.
Oh, that is the general knowledge of friction. You are telling us extents of friction, which we know. We've just learned. 1. Alvina. Help me.
Yes, sir.
Laws of friction.
Sir, please. Friction depends on magnitude of contact.
The magnitude of contact. Alvina, magnitude of contact, it's not clear. What do you mean?
Okay, sir. So friction only happens when two bodies are in contact with each other.
Yes, we know. Yes. Okay, Eresi is here. Eresi,
Said the amount of friction. Said the amount of friction is proportional to the normal force exerted between the surfaces.
Okay. I think Elvina was close. So frictional force depends on 1, the nature of the surfaces in contact and their composition. So it depends on the nature or the roughness. Here, let's use the roughness of the surfaces in contact. depends on the roughness or the nature of the surfaces in contact and their composition, what and how they are made of. Okay. You see, friction is such that when the surface of the two bodies in contact is so rough, then friction is great. That is why the vehicle tire has lines along. No vehicle tire is made without smooth surface. No, it has to be rough so that it can grip the road very well. So it depends on the smoothness of the surfaces in contact. Okay, and their composition. That's the first law. The second law, too, is that, what's the second law? Hey, somebody to help me. It also depends. I think that was what, okay, Chrysler, your hand is up. Go ahead. Chrysler, go ahead with your contribution.
About it
Okay.
at rest, the friction is equal to the applied force.
We will talk about that. We'll come to that. Then the other point is that frictional force also depends on the force, okay, which is pressing the two bodies in contact together. And this force which presses the two bodies in contact, okay, is what we call as a normal reaction, or the normal reactional force. It is called the normal because when the body lies flat on the surface of the ground or on the ground, this force which presses the two bodies together is always perpendicular to the surface on which the body lies. That is why the force is called the reaction, the normal reaction. Okay, it also depends on the force pressing the two bodies together. So F, frictional force, okay, frictional force depends on the force coming. Let me change my marker. So frictional force depends on the force pressing the two bodies in contact. This force is the normal reaction, which is perpendicular to the surface. So we say that F is directly proportional to normal reaction, is sometimes represented by the letter capital N or capital R. Okay.
Mr. Dia.
Hello.
Please, the board is blurry.
Really? I think it's the marker.
Yeah.
Hello.
Please, can we say that frictional force is proportional to the weight?
The weight, you are not wrong, because you see, when the body lies flat, let me reposition the camera. When the body lies flat on the ground, like this, okay, the weight is in line with the direction of gravity. So, and once it lies flat on the ground, the reactional force, which is this force which presses the body to the surface of the ground, is opposite, equal in magnitude, but opposite in direction to the weight. So the reaction R is equal to W. But because the reactional force is the force which presses the two bodies, okay, together or in contact, we refer friction to the reaction and not the weight, even though they are of the same magnitude, but oppositely in direction. Please, have I answered your question? Hello, have I answered your
Yes,
question?
please.
Okay. Now, the last one is that.
Yes, please.
Okay. The last one is that frictional force does not depend on the cross-sectional area. It does not, frictional force doesn't depend on the cross-sectional area of the body. And this is what I mean. Let's assume we have this surface and the duster, okay, tries to slide or move. You see, the extent of friction existing between the book and then the duster does not depend on the cross-sectional area of the duster. The reason is that this is one area, cross-sectional area of the duster. Okay. This is another cross-sectional area of the duster. And then this is the third cross-sectional area of the duster. If I place the duster on the book like this, okay, its weight, mg, will never change. And so the normal reaction will still be equal to the weight. When I change the area to this cross-sectional area, will the weight change? Class, will the weight change?
Yes.
No, the weight will never change. It is still mg. Once the weight isn't changing, the reaction which holds the two stuff together will never change, even though there is a change in the cross-sectional area to the book. If I turn it this way, I've changed the area in contact with the book, correct? Please, is that okay?
Yes.
In changing the area of contact, will the weight change? Will the weight of the duster change?
No.
And so the reaction will also not change. So irrespective of the different areas in contact, because the weight doesn't change, the reactional force on which frictional force also depends will never change. And so frictional force does not depend on the area in contact. No, it depends on the nature of the surface, the two surfaces in contact. It depends on the normal reaction. Is that okay? These are the two key conditions on which, but does not depend on the area in contact. No. If you have any question, you can quickly ask so we can continue. All right, so these are the laws of friction. The laws of friction, if you were asked to. Now, list 3 examples of sports that exhibit projectile motion. Oh, as for this, we have a lot to tell. So let me call some individuals. Okay, Adwa Sewa, I'm starting with you. Leanne, get ready.
Javelin throw.
Okay, so a throwing of the javelin missile. Good. Leanne, get ready. No, I'm on you.
Say the happy is jumping.
Which jumping? Which one?
High jump.
Oh, yeah, high jumping. I won't buy this. Come again. Okay. Think through and then come again. Yes. Chrysler, Lauren, Eurasi, Eurama. I'm not calling names. Sports. So, throwing of the jump, Chrysler, go ahead.
Said there was a mistake.
Oh, no, it's not a mistake. Okay, I'll do Asante.
Please, golf.
Golfing. Yes.
Javelin throw.
Pardon?
Javelin throw.
We've mentioned that. Short.
Football. Hammer. Football.
Footballing. And then short putting. Okay.
Yes, please.
Somebody wanted to say table tennis.
Please, table tennis.
Hey, TT, okay. Sometimes. Helvina.
Say please, Dick's throw.
Discuss. Okay. All right. I just shot the discuss and it's yes, clear. All right. Let's continue.
Sure.
Now a ball is projected horizontally from the top of a tall building. Listen to the question. A ball is projected horizontally from the top of a tall building. State the factors on which the distance at which it strikes the ground from the foot of the building depends. I take it again. A ball is